Hello everyone, today we are continuing the discussion on proofs with this justifications and making conclusions notes. So now we're taking it even a step further. We're going to remove some of those algebraic proofs that we see and look more at these statements that deal more with the definitions that we've been using. So definition of complementary angles, definition of congruence, definition of right angles, and so on. And so again, a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. And so just to recall, remember definition of complementary angles, that just tells us that the two angles add up to equal 90. So let's say they're angle 1, angle 2. Supplementary, they just add up to equal 180. Definition of congruence, that one would say if AB is congruent to BC, then AB is equal to BC. Definition of right angles, so a right angle, if angle 1 is a right angle, that means that the measure of angle 1 is 90. Straight angle, that one was if a angle is a straight angle, then that angle is equal to 180, and so on. So for this first video, we're just going to be looking at writing the reason for each conclusion. So we're given a statement and then we're concluding something from it. So for number 1, I'm given that AM is congruent to WU. My conclusion is that those segments are therefore equal to one another. And so when I'm going from congruence to equal or vice versa, that is just my definition of congruence. Okay, number 2, I'm given that E is the midpoint of BD. So I can even just draw that. I have BD. And I'm given that E is the midpoint. Well, I know from the definition of midpoint, my conclusion here is that BE is therefore congruent to ED. And so that just came from the definition of midpoint. So a lot of times if there is a vocabulary word in that given statement, like this one at midpoint, your next statement, you're going to use the definition of midpoint for that. AY and angle YAK are a linear pair, and my conclusion is that these two angles are therefore supplementary. So here I'm given that these two angles are a linear pair. It is really tempting to go and say that this is definition of linear pair. But actually, if you go back to your last unit, the definition of linear pair was that it's just two angles that are adjacent and form a straight angle. Now, the conclusion that these are therefore supplementary, that actually comes from the linear pair postulate. And you can find that in the previous unit's notes. Okay, number 4, I'm given that angle TOM is the supplement of angle SUE. My conclusion is that they add up to equal 180. So here I'm given that is the supplement, in other words, they're supplementary. So this one's going to come from the definition of supplementary angles. Okay, number 5, I'm given that A is in the interior of angle GLD. My conclusion is that the measure of angle GLA plus the measure of angle ALD is equal to the measure of angle GLD. So for this one, it might be helpful to go ahead and draw a picture. So if I draw a picture of this, I have angle GLD, and I'm told that A is in the interior. And so then my conclusion is that GLA plus ALD is equal to the whole thing, and that postulate tells us that is the angle addition postulate. The two parts of the angle add up equal to the whole angle. Now this last one I'm just given a picture. So I'm given this, angle 8 and angle 9. My conclusion is that angle 8 and angle 9 are vertical angles. And that comes from the definition of vertical angles. So a lot of these reasons are going to be the same reasons that we use in proofs, and you'll see in the next video. So will be good to have these on hand just to see some examples of when you'll use these reasons, because you will see this a lot in the coming unit.